Hello everyone, welcome to Maths Smart Tips. In this video, we are discussing about a small topic of PDE, which is compatible system of first order PDE. That means in this video, we are actually compare whether two system of partial differential equation or rather first order partial differential equation are compatible or not. So let's start, and before starting the solution, I am requesting you all, those who are new in my channel, please like the video, comment if you have any doubt in the comment section below. And don't forget to subscribe the channel, and more videos of PDE or many other topics already discussed in the channel, so you can get the link in the description, and also I share the playlist of PDE here in the I tab. So let's start. First, what is compatible system? Two first order PDE are said to be compatible if they have a common solutions. The compatibility conditions for the PDE, these two are PDEs f xyz pq, this is equal to 0. This is one PD, first PD, and the second one is g xyz pq equal to 0 is here. This is the condition del fg by del xp plus p del fg del zp plus del fg del yq plus q del fg del zq. This is equal to 0. So we need to check this condition only. If this condition holds, then we must say that the two system of PDEs are compatible. So let us take an example. Let us take the first PD, 2 PDE, this p square plus q square equal to 1, and second one is p square plus q square equal to into x equal to pz. So let us take f xyz pq equal to this one and g xyz pq equal to this one. Now we have to find these partial derivatives, 4 partial derivatives, 1, 2, 3 and 4. We have to calculate these 4 partial derivatives. So first we calculate del fg del xp. This is equal to del f del x del f del p by del z del x del z del p. So this is equal to del f del x, means there is no function of x, so del f del x means 0, del f del p means 2p, del g del x means p square plus q square, and del g del p means minus of z. Sorry, del f del p means 2px minus p. So this one, this is the first Jacobian, so this is equal to minus 2p into p square plus q square. Now we calculate the next Jacobian, del fg del zp. This is equal to del f del z del f del p and del g del p. So this is equal to 0 minus 2p minus p and 2px minus z. This is equal to 2p square. Then del fg del yq, this is equal to del f del y del f del q, del g del y del g del q. This is equal to 0, 2q, 0 minus 2qx, which is equal to clearly 0. And the last one is del fg del zq. This is equal to del g del z del f del z del f del q del g del z del g del q. This is equal to 0 minus 2q minus p and 2qx. And so this is implies simply 2px here. So now we put these values in this equation, del fg del xp plus p del fg del zp plus del fg del yq plus q del fg del zq. So this is equal to minus 2pq minus 2p square q plus 2pq plus 2pq square, which is clearly equal to 0. You just put these values. Oh sorry, this is equal to 2pq. This is not, this is 2pq. So this is clearly gives the value 0. Hence the PDEs, that is the system of these two PDEs, are compatible, fx and gn. So this is the content for this video. If the content is helpful, then please give a like to this video, share it with your friends and subscribe to the channel. Thank you friends. See you again in the next video.